is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So what that's telling us is for an angle to be in standard form here, its vertex, which is your turning point of your angle right here, is right there at the origin at the point 0, 0, and it has one of its sides has to be right there on the positive x-axis. So that side of our angle does not change. We're going to move this angle right here, but this side does not change. The ray on the x-axis is called the initial ray. And the other ray is called the terminal ray. So if we label that over here, this side right here is our initial ray. That's the part of the angle that's there on the x-axis. It will always be there if it's in standard form, and everything we're going to deal about is going to be in standard form. The terminal ray would be this side. Over here. Okay, when we're talking about angles on the unit, not on the unit, well, on the unit circle as well, but we're not doing that until tomorrow. When we talk about angles on the coordinate plane, on the xy axis, and they're in standard form, we can talk about those angles as positive angles or negative angles. Okay, so if we have angles that are positive, those are angles that go in the counterclockwise direction. So counterclockwise rotations result in positive angle measures. So clockwise rotations result in negative angle measures. And if I take this ray right here and I spin it all the way around, if you think about, let's see if I got all this spinner. Okay, so if you think of this initial ray right here, if you think of them like hands on a clock, right? This one is never going to move, right? It'll always be right there. The pink one right here, it can spin around and create different angles. So whenever we see these words clockwise and counterclockwise, those might not be words that you think about very often, but if you look at the clock, which direction are the hands moving? They're going this way, right? So that is clockwise. It's like a clock. Counterclockwise would be the other direction, the opposite way that a clock spins. So if you can think about our second hand here, right, as it goes around, because end of it, as it spins around, it's making a circle, right? So 1 full revolution for this is going to equal 360 degrees. Okay, so you will notice on this graph right here that they have given you, they have 4 angles already marked for you, right? The initial ray right here, the one that I've marked in blue, is always going to be on that positive x-axis. And that initial ray, that is at 0 degrees. That's where we start from. Then, it's like our starting point, so it's called the initial ray. So that is at 0 degrees. And then if we go counterclockwise, which is this direction, the vertical y-axis part here, the positive part, that's going to be 90 degrees because that makes a 90-degree angle in the counterclockwise direction, right? And so every, basically like quadrant that we go, we get another 90 degrees. So this is 0 degrees, this is 90 degrees, this is 180, this is 270. If we went all the way back over here, what would we be at? 360, right? If we spun all the way around. So the first thing that we're going to do is we're going to try to sketch some angles. We're just going to estimate for this. I could pass out protractors and we could actually measure it, but we're going to estimate. So 75 degrees, or well, for all of these, let's do this first. For all of these, your initial side is on this axis right here. So one side is going to be right here every time. All right, that's where our initial side is. We want these to be in standard position for this. So our terminal side determines the measure of our angle. So when I want to sketch 75 degrees, it is positive, so that means I need to go in this direction. Which quadrant is it going to be in? If you guys don't remember, we got first quadrant, second quadrant, third quadrant, and fourth quadrant. Drew tells me it's going to be in the first quadrant. How do you know? It's lower than 90, so I'm not going all the way to 90 degrees, right? So 75 is going to be maybe somewhere about there, and I'm going to label this 75 degrees. And we're just estimating right now to get an idea of what it is. And we're going in that direction right there. We're starting at that initial ray right there, and we're ending up at that terminal ray. That would be about 75 degrees. Okay? The second one is negative 160. So if I'm thinking of the quadrants here, this is first quadrant, this is second quadrant, this is third quadrant, this is our fourth quadrant. Which quadrant is this one going to be in? Third. Because, why is it not in the second? It's negative. So it's less than 180, so it's less than halfway, but it's negative, so we're not going in this direction. Second 160 would be about right here in the second quadrant, but we are going backwards. So we would start here and go this direction. That'd be 90. That'd be 180, so 160 would fall somewhere about right here. So that would be negative 160 degrees. Okay, everybody with me there? All right, now we got 430. Good question. What quadrant is that going to be in? Why none?
Because it
only goes up to 180.
Well, most of them, here's the thing. So I'm sure that you guys have all watched skateboarding, skiing, snowboarding, something like that on TV. Maybe at least once. Okay? And what would you call it if somebody, like, on a skateboard jumps up and spins around twice. Be a good trick. It wouldn't be a 360. So if they spin around twice, or snowboard, let's say a snowboard. 360 is only spinning once.
720.
720.
No, I had it.
Right? It'd be a 720. Right? Because they have spun around 360 once and then 360 again. So if we add 360 plus 360, we'd get 720 for that.
Wait, so we just added them
Yeah.
together.
Yeah. So,
You got put 2 on it.
so, let's practice this. I need everybody to stand up. Stand up where you're at, okay? Stand up beside your desk. Let's face this way right here. Okay, we're going to face this way. That's going to be our 0 degrees right there. Kind of think about if you had a drone above you watching it from above, okay? All right, so I need us. Our initial ray is right here, and it's not moving. It's going to be impossible for us. We could do 75. We could do 160. We're not going to be able to do any more than that because of the limitations of the human body, right? But imagine our initial ray is right here. We need our terminal ray. Put your hands out for your terminal ray. You're not smacking people in front of you. All right. All right. We need 430 degrees. So let's go 90 degrees. 180. 270. 360. How much further do we need to go? 2 more. So if we do 430 minus 360, we've already been 70. So we need 70 more degrees. So move 70 degrees. Not quite 90. Aiden already had it. Right? You should be pointing about this direction. So you can have thank you. You can sit down. You can have angles bigger than 360. So what would happen is you would go all the way around and then back to about here.
So all the way around and then like that.
Yeah. Oops. Wait a minute. Yep. So all the way around, there's 360, and then an extra 70 right there. That would be 430 degrees. So first quadrant is where it would end up. All right. Okay, so we are not going to be limited just to 360 degrees because we can spin around more and more and more and more, right? So it's infinite. You could spin around, you could graph 1,000,000 degrees. I'm not going to ask you to do that, but you could. Because it's going to spin around a bunch of times and then end up somewhere, right? So we are not limited to just 360 degrees. So let's look at something that's going to be really important to what we're doing, okay? All right, so this is going to be very important to really everything we do in this unit, okay? And that is coterminal angles, okay? Angles in standard position with the same coterminal side are called coterminal angles. So, we just did 430, right? And when we did 430, we spun all the way around, and then we had to go 70 more degrees, right? So, 430 and 70 degrees are coterminal angles, because I could tell Aiden to spin 70 degrees, and I could spin 430, and we'd end up in the same position, pointing to the same spot there, right? So, some examples right here. I couldn't mark this one because it wouldn't let me do that. For example, 30, if I graph this angle right here, that's 30 degrees, right? It's in standard position, 30-degree angle, okay? It is going to be the exact same, I just copied and pasted this circle right here, exact same as negative 3 30. Right? Negative 330 is the opposite direction, 330 degrees. This would also be the same as 390. 390, you always start from the side right here, right? You always have to start from that initial side. If I went all the way around, that'd be 360. And if I added that 30 degrees there onto it, then that would be 390 degrees. All three of those angles look the exact same whenever you graph them, right? So they would be called coterminal angles. Their terminal side is in the same spot, okay? So here's the neat thing about this, especially with degrees, it's really easy to find coterminal angles. Because to find a coterminal angle, you can add or subtract 360 degrees. Okay? You just have to add or subtract 360 degrees. Because, think about it, if I am at 70 degrees, where we were just a little bit ago, keep our desk on the floor, where you are 180 degrees in the floor there. All right. Okay, so, all right, if I'm right here at 70 degrees, I can add 360 to it, and I end back up at the same spot, but now I've got 430, right? And I could keep doing that. I could add 360 degrees again, right? And then if somebody's got a calculator, what would that be? What? 430 plus 360. 430 plus 360.
790.
790, right? And then I could spin around again and again and again and again. And it would still be that same coterminal angle.
Wait.
Okay?
So if you keep adding 360
Yeah,
to the number?
to the number, yes. So like for example here, 30 plus 360 gives us 390. That's this one. Oh, no, it's not that one. Oh, didn't mean to do that. 30 plus 360 equals 390. That's a coterminal angle. That's this one over here, right? I could do 30 minus 360. That would give me negative 330. That's this angle right here, right? And we could keep doing that. This isn't like I could subtract 360 again or add 360 again. You could just keep doing that, and there's like an infinite number of coterminal angles.
And you're subtracting all about 30?
You're starting with 30. So you're either adding 360 to 30 or you're subtracting 360 to 30. Let's look at our next problems. Okay? All right, so there's some different ways that I'm going to ask you to do this. So for these problems, I have asked you to give me one negative and one positive coterminal angle for each angle measure. Okay? So it depends on what they have given you, whether you need to add or subtract, right? So if I've got 50, that is already positive, right? If I want the negative angle that goes with it, what would I do? I would do 50, sorry, doing this to me. All right, so I would do 50 degrees minus 360 degrees, and that is going to give me negative 310 degrees. So that is one coterminal angle. It asked me for another positive coterminal angle. So if I want a positive coterminal angle, I'd have to take 50. I'd have to add 360. Now this one's going to be bigger than 360, obviously, but I'll get 410. Okay? Those don't have to be the answers. They're just the easiest ones to get to, right? If I wanted to, I could do 50 plus 360 plus 360. I could add 360 two times. Now, there's not really any point in doing that because you've already got your two answers that you have to have. But if I did that, if I did 50 plus 360 plus 360, I'd get 770. Right? And I could keep doing that and get a lot of answers, but they only asked me for one positive and one negative. Okay, so if we look at example 2, Carlos, Ayla, join us back over here. If I look at example 2, that number is already bigger than 360, right? So I could add 360 to it. That would be a coterminal angle. That would work. Or I could do this, because if I subtract 360 from 480, I'm still going to get a positive number, right? So I could do 480 minus 360. And that is going to give me 120 degrees. So that is another positive coterminal angle. Now, it'd be okay to do 480 plus 360 and get, let's see, 480 plus 360 is going to give me 840. You could have that one as your positive angle as well. It's fine. And then, if I want to get to a negative coterminal angle, what am I going to have to do here? I'm going to have to minus 360 twice, right? So I could do 480 minus 360 minus 360, and that'll be negative 240 for that. Okay, try the next two on your own. Okay, try finding those coterminal angles on your own. All right, check with your neighbors, see what you got. All right. Okay. All right, so let's see what you guys got. For negative 120, raise your hand if you got one for me. Hey, well, what have you got?
I got negative 480.
Negative 480. So we did negative 120 minus 360. That'll give us negative 480. That's good. All right, Alex, what'd you get? $240. So we do negative 120 plus 360. We'll get 240. So that is also a coterminal angle. All right. Anybody get anything different?
I got 600 because I did 360 plus 360.
Yeah, that'll work. Negative 120 plus 360 plus 360. We'll give you guys quiet. We'll give you, oops, sorry, I got that wrong. Will be 600. That would work. And you could, this could go on forever, right? We could keep doing that as well. Yes. No. I was just seeing if anybody else did it any differently. So that's fine. Okay? All right. What about number 4? Katie, what'd you get on number 4? Okay, so 135 plus 360 is going to give us 495. I think that looks good. William, what'd you get? Negative 225. That sounds right. Negative 230 sounds not right. You got to have 5 on it. You did something wrong in your calculator. All right. You asked your calculator the wrong question was the problem. Okay. All right. So, all right. Now, the state of North Carolina believes that you guys need to know about radian measures. And I said this earlier. Radian measures are something that is used a ton in higher level math. Now, I know that there are a lot of you that do not plan on doing much math past this course, or Math 4 is as far as you plan on doing much of. However, you never know what you may end up doing, where you may have to have like a pre-calculus or a calculus class for something. So it's not bad that they make us do an introduction here. If it were me, I would teach the unit circle just with degrees, but I don't get to pick here. I have to teach what they say I have to teach. So we're going to learn about radian measures, and to do that, I need to give you guys a tiny piece of string, and I need to finish cutting my little tiny pieces of string. So give me just 1 second here. These are not going to be perfect at all. All right. I think I've got enough here. Okay. Okay. All right, I'm giving everybody a tiny piece of string that hopefully is pretty close to the length of that radius of that circle on your neck.
No, it's not. But like,
Tiny piece of string. Yeah, it may unravel. Okay, everybody have a tiny piece of string. He's wrong, but
Yeah, isn't it 362?
It's 365.
you're also wrong. 365.
Good.
Except for 366 every fourth year.
I
I think that he sometimes says that to remember how many degrees are in a circle. I guess it's close enough for him. All right, so I'm gonna draw myself a circle here because I can't reach that one. So I'm gonna draw a circle the best I can here and show you guys what I want you to do. Okay, let me put this back down so you guys can see better. Okay. All right, so. My circle's bad. Alright. Okay, so everybody should have a piece of string, and that piece of string should be pretty close to being the length of your radius. It might not be perfect because it's kind of hard to cut it right. So I'm going to also get a piece of string the length of my radius here. Okay? For my circle. So I have a piece of string that is the length of my radius. Okay? So what I want you to do is take your piece of string, and it'll be easier for you than it is here for me on the board because it's hard. It's just easier when it's flat. But you're going to lay your string along the edge of the circle. It's hard to do up here because obviously I can't lay it flat. Ugh, so hard to do up here. Plus I'm erasing my circle. But you'll lay it along the edge of the circle, and I want you to make a mark. Put a point right there at the end of that length of string. Okay? So you're laying your string along the edge of that circle, and you're putting a dot at the end of that string. Okay? To the end of your little string. Yeah. You want to go to the end of your string. You lay your string. Yeah, you got to start spinning. It's not a radius. Along the edge of the circle.
That's what I'm in mind.
Yeah. It's not a radius. It's the edge of the circle. Then you're going to take your string again from that point and go to the next point along the edge of the circle. Okay. You're going to put a dot at your next point. Okay? Then you're going to keep going all the way around the circle. So, I'm just going to put some dots on here. Because my circle is not really a circle. And it's not going to work that great for me. But you guys can do it a little bit better than I can. It's not super easy. This is estimating. Yeah, so keep going around. And I'm going to try to do it up here, I guess, best I can. Because I need to be able to show you guys.
Okay, I got it.
Get some better scissors for this.
You only have 4 dogs.
This string is so gravelly.
I know it's not the best string for this particular activity, but all right. Has everybody got their dots? Okay.
It's okay if I only have like 4 dogs.
And I know you've probably messed up.
I did 5 dogs. I've got 7. I did 6 dogs. Is it supposed to be even all the way around? Because I'm not getting it.
Yes, it should be even all the way around because it should be the same length of your string the whole way around. The last dot's the question. If your string was longer than the line, it'll mess it up. And I know I did not.
Okay, mine only had 4 dogs. Mine's like a string and a
If your string is too long, it will mess you up a little bit. You'll still get the same general idea. Okay, I think I've done mine fairly well. Okay. So I have 1, 2, 3, 4, 5, 6 dots that I drew on mine. And I think I've probably done mine pretty well. Now, if your string is longer than your radius, because it was not cut well, because I was just cutting those pretty quickly. If your string is longer than your radius, you will probably have fewer dots. Now, you probably should still have 5 dots. Unless it was way off. You should probably still have 5 dots. I don't think you should just have 4, unless your string was way off. But I want everybody to draw a line to your first dot. No, you don't need string anymore. Okay? This angle right here, we could get out protractors and measure it. 75 is probably pretty close to what it's going to be. But we can call it something different. We can use a different way to measure these angles. Okay? So what we can call it, instead of calling it however many degrees it would be, because if we do degrees, there's 360 degrees in an angle, and we would call that, we'd measure it, it might be 75 degrees. Another way we can call this angle right here is we can call it 1 radian. Okay? It is the angle that goes with 1 radius traced around the edge of the circle. Now, if you do it perfectly, if I try to draw all of these in here, if you do it perfectly, it should end up looking like mine right here. Now, some of you guys maybe only have 5 dots, and your pieces may look all exactly the same. You might not have this little sliver right here. But if you do it perfectly, it should look like I have, where you've got 6 pieces that are all the same size, and then you've got a little bit of a sliver left over here. Okay? Now, each one of these angles right here is what we call a radian. So each angle that we have right here is a radian, except for our last little sliver. Okay, and we'll talk about what that'll be here in a second. Because the length of the edge, that arc length on the edge, was a radius. That was the length of your radius. Okay, so that's where this comes from. And it does not matter what size your circle is, right? Because your circles there are all the same size. Just because I printed out, I thought about doing some different size circles. Usually when I do this with pre-cal, we do different size circles. But that just seemed like it would take too long. My circle up here was a different size than your circle. But I still ended up with the same number of pieces, right? Because if you have a smaller circle, you'll also have a smaller radius, right? So whenever you do the radians, you'll get the same amount. If you have a bigger circle, you also have a bigger radius, but the angles will end up being the same. So every circle has the same amount of radians in it. And I think I have that on the next slide here. Every circle has the same amount of radians in it. So let's fill in those blanks first. I've already told you the definition for this. A radian is a unit of angle measure based on arc length. One